3.3 Function notation. Function notation is literally when you put an equation of a line in y equals mx plus b form and you redo it as f of x. So f parentheses x close parentheses is equal to mx plus b. So you're just switching out the y with the f of x. Sometimes you're going to be able to evaluate for these functions as well, and when you evaluate, you're just plugging in values for the variable x and simplifying. So if we look at example 1a, it tells us to evaluate f of x is equal to negative 4x plus 7 when x is equal to 2 and x is equal to negative 2. So when we plug in the value for x, we're going to change out that x in f of x as well as the x within the expression also. So if we do x is equal to 2, we're going to have f of 2 is equal to negative 4 times 2 plus 7. That f of 2 is then simplifying to be negative 8 plus 7, which is then negative 1. And the reason why we put this 2 in the parentheses where that f is to tell ourselves and whoever's looking at this that we plugged in that 2, or we substituted in that 2 for x in the expression that was on the other side of that equal sign. For negative 2, we can do f of negative 2 is equal to negative 4 times negative 2 plus 7. From here, we're going to do the negative 4 times the negative 2, which is a positive 8. So f of negative 2 is equal to 8 plus 7. 8 plus 7 is 15, so f of negative 2 is equal to 15. For examples B and C, we're evaluating the function when x is equal to negative 4, 0, and 3. So for B, we're going to start this one by doing f of negative 4, which will give us 2 times negative 4 minus 5. The 2 times negative 4 gives us negative 8, so f of negative 4 is equal to negative 8 minus 5. Then we can do f of negative 4 is equal to negative 13. Next, we plug in that 0 for x, so f of 0 is equal to 2 times 0 minus 5. The 2 times 0 gives us 0, so f of 0 is equal to 0 minus 5, which gives us f of 0 is equal to negative 5. Lastly, we'll do f of 3. So that's going to be 2 times 3 minus 5. The 2 times 3 gives us 6. So f of 3 is equal to 6 minus 5. 6 minus 5 is 1. So f of 3 is equal to 1. For C, we're given g of x is equal to negative x minus 1, and we're finding for g of negative 4, g of 0, and g of 3. So we're going to start with that g of negative 4. And we're just going to plug that negative 4 in, so a negative times negative 4 minus 1. The opposite of negative 4 is positive 4, so g of negative 4 is equal to 4 minus 1. 4 minus 1 is 3, so g of negative 4 is equal to 3. Next, we'll do g of 0. So the opposite of 0 minus 1. The opposite of 0 is just 0, so g of 0 is equal to 0 minus 1. 0 minus 1 is negative 1, so g of 0 is equal to negative 1. And then lastly, we do g of 3. So the opposite of 3 minus 1. The opposite of 3 is negative 3 minus 1 is negative 4. So g of 3 is equal to -4. For example 2, it tells us let f of t be the outside temperature in degrees Fahrenheit t hours after 6 a.m. Explain the meaning of each statement. So for A, they give us f of 0 is equal to 58. So the T is the temperature in degrees Fahrenheit. That 0 that's being plugged in for that variable in the parentheses just means that when you have your initial value of the function is the 58, so the temperature at 6 a.m. is the 58 degrees. So at 6 a.m., the temperature is 58 degrees. For B, it says f of 6 is equal to n. So with this, the output of f when t is equal to 6 is n, which means the temperature at noon, because 6 a.m. plus 6 hours is noon, means that your temperature is n degrees. So at noon, your temperature is n degrees. For C, it tells us f of 3 is less than f of 9. So if we added that 3 hours to the 6 a.m., it would tell us that at 9 a.m., the temperature is less than at 9 hours after 6 a.m., which would then be 3 p.m. So your temperature at 9 a.m. is just less than the temperature at 3 p.m. Your next one for C tells you in example 2, let f of t be the outside temperature for the same exact thing, but now we're working with the starting temperature at 9 a.m. Explain the meaning of each statement. So for A, we have f of 4 is equal to 75. If f of 4 is 75, then that means that after the 4 hours from that 9 a.m., the temperature is at 75 degrees. So then 9 a.m., add the 4 to it. So that's 1 p.m. Our temperature is 75 degrees. For B, we have f of m is equal to 70 degrees, or 70. So if f of m, so at m hours after, then it would be 70 degrees. For C, we said we have f of 2 is equal to f of 9. So if we do the 9 a.m. plus the 2 hours, that gives us 11 a.m. And then if we do the 9 a.m. plus the 9 hours, so that's 9, 10, 11, 12, 1, 2, 3, 4, 5, 6 p.m. So the temperature is the same at both 11 a.m. and 6 p.m. And then for D, we have f of 6 is greater than f of 0. So 9 a.m. plus 6 hours, that's 3 p.m., is greater than, so the temperature at 3 p.m. is greater than the temperature at 9 a.m. Skip one. Yes, okay. Our next example, it tells us to find the value of x so that the function has the given value. So we have for A, h of x is equal to 2/3 x minus 5 when h of x is equal to negative 7. So that just means that the h of x is negative 7. We're plugging that in for h of x in our equation and then solving for x. So this is going to give us negative 7 is equal to 2/3 x minus 5. So we're going to start this one by adding the 5 to both sides. We get negative 2 is equal to 2/3 x. To get the x by itself, we're going to multiply each side by the reciprocal of that 2/3, which is 3/2. Those 2's are going to cancel, so it's just 3 times negative 1, which is negative 3, is equal to x. So x is equal to negative 3. For B, we're given f of x is equal to 6x plus 9 when f of x is equal to 21. So we're going to take that 21, we're just going to plug it in for f of x to give ourselves 21 is equal to 6x plus 9. I'm going to move that 9 over by subtracting it from each side. So 21 minus 9 gives me 12 is equal to 6x. We divide each side by the 6, and x is equal to 2. So for C, we have g of x is equal to 1/2 x plus 3, and g of x is equal to negative 1. So again, we're going to plug that negative 1 in for g of x to give ourselves negative 1 is equal to negative 1/2 x plus 3. We subtract the 3 from each side, so that gives us negative 4 is equal to negative 1/2 x. We multiply each side by the reciprocal of that negative 1/2, which is just negative 2. So this gives us 8 is equal to x, so x is equal to 8. For our next part of this lesson, we're just graphing the linear function by completing the function table. So this is all something that we've most likely have done before. I will give you a function table with values of x, and you're just plugging them in for x, solving for f of x to get your ordered pair x comma f of x. So for our first example A here, we have f of x is equal to 2x plus 5. Our given x values that we're working with are negative 2, negative 1, 0, 1, and 2. So we're going to do 2 times negative 2 plus 5, 2 times negative 1 plus 5, 2 times 0 plus 5, 2 times 1 plus 5, and 2 times 2 plus 5. The 2 times negative 2 is negative 4, plus 5 is 1. 2 times negative 1 is negative 2, plus 5 is 3. 2 times 0 is 0, plus 5 is 3. 2 times 1 is 2, plus 5 is 7. 2 times 2 is 4, plus 5 is 9. So this gives us ordered pairs of negative 2, 1, negative 1, 3, 0, 5, 1, 7, and 2, 9. So on our coordinate plane, to graph these, for the negative 2, 1, we're going to go to the left 2 and up 1, plot our point. For the negative 1, 3, we're going to go left 1, up 3, plot our point. 0, 5 is on the y-intercept, or y-axis, and is the y-intercept. 1, 7, we're going to go to the right 1, up 7, plot the point. And then 2, 9, we're going to go to the right 2, up 9, and plot the point. So then from here, we just draw a line through these points and make sure that we have arrows at the top and the bottom of our lines. Now, it's a good idea with these that you have those lines drawn throughout the entire coordinate plane, so it goes all the way through both sides of that coordinate plane. For example B, we have f of x is equal to 3x minus 2, and given x values of negative 2, negative 1, 0, 1, and 2. So again, we're just going to substitute these in and simplify. So we're going to have, for the negative 2, 3 times negative 2 minus 2. For the negative 1, 3 times negative 1 minus 2. For the 0, 3 times 0 minus 2. For the 1, 3 times 1 minus 2. For the 2, 3 times 2 minus 2. going back up to the top. 3 times negative 2 is negative 6, minus 2 is negative 8. 3 times negative 1 is negative 3, minus 2 is negative 5. 3 times 0 is 0, minus 2 is negative 2. 3 times 1 is 3, minus 2 is negative 1. 3 times 2 is 6, minus 2 is 4. 3 minus 2 is not negative 1, it's positive 1, I'm sorry. So these ordered pairs that we are going to have are negative 2, negative 8, negative 1, negative 5, 0, negative 2, 1, 1, and 2, 4. So from here, we're just going to plot these points. We have negative 2, 8, so we're going to go to the left 2, up 8. Plot the point there. Then negative 1, negative, this should be a negative 8, not a positive 8. Hold on. So then this, oops, erase the whole thing. Alright, so negative 2, negative 8. We're going to go to the left 2 and down 8. Then plot that point. That's right. Then we have negative 1, negative 5. To the left 1, down 5. 0, negative 2. Just down 2. 1, 1. To the right 1, up 1. And then 2, 4. To the right 2, up 4. From there, we draw the line through those points. And then we're done, making sure that there's arrows at the top and the bottom of our lines. For our next example, it tells us that we have g of x is equal to negative x plus 4, and our given x values are negative 2, negative 1, 0, 1, and 2. So we are going to plug these values in. So it's just the opposite of negative 2 plus 4, the opposite of negative 1 plus 4, the opposite of 0 plus 4, the opposite of 1 plus 4, and the opposite of 2 plus 4. So the opposite of negative 2 is positive 2, plus 4 is 6. The opposite of negative 1 is 1, plus 4 is 5. The opposite of 0 is just 0, plus 4 is 4. The opposite of 1 is negative 1, plus 4 is 3. The opposite of 2 is negative 2, plus 4 is 2. So this gives us negative 2, 6, negative 1, 5, 0, 4, positive 1, 3, and positive 2, 2. So to graph these, negative 2, 6 to the left 2, up 6, negative 1, 5 to the left 1, up 5, 0, 4, 1, 3, 2, 2. Making sure that there's arrows at the top and the bottom of your lines, and then you're good. For our next one, we have h of x is equal to negative 3/4 x minus 1. So our given x values are negative 8, negative 4, 0, 4, and 8. So I'm just going to plug these in. So negative 3/4 times negative 8 minus 1. Negative 3/4 times negative 4 minus 1. Negative 3/4 times 0 minus 1. Negative 3/4 times 4 minus 1. Negative 3/4 times 8 minus 1. So with the top one, the 4 is going to become a 1. The 8 becomes a negative 2. Negative 3 times negative 2 is 6. Minus 1 is 5. For the negative 4, the negative 3 times negative 1 is 3. Minus 1 is 2. The negative 4 times, the negative 3/4 times 0 is 0. Minus 1 is negative 1. The negative 3/4 times 4 is just negative 3. Minus 1 is negative 4. The negative 3/4 times 8 is negative 3 times 2, which is negative 6. Minus 1 is negative 7. So this gives us negative 8, 5, negative 4, 2, 0, negative 1, 4, negative 4, and 8, negative 7. So on our coordinate plane, the negative 8, 5 is here. Then we have negative 4, 2, which is here. 0, negative 1 is here. 4, negative 4 is here. And then 8, 7. Your other point, or your last point, was at 8, negative 7. So 8, 1, 2, 3, 4, 5, 6, 7. Plot the point, and then draw your line through your points. For example 5a, it tells us that the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function f of x is equal to 350 minus 125x represents the second flight, where f of x is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? Explain. So if we look at this graph here, we can find our rate of change. We're going down by 100 and over 1 hour. So our slope there is negative 100. So with this, the one that would go faster would be the second flight, because your miles per hour would be higher. Now, you want to look at this and see for both of them that this one takes 3 hours to get to where they are. If we're using f of x is equal to 350 minus 125x, and we want our y to be 0, we can plug in that 0 for y, or f of x. Oops. And see what we get for x. So with this, I would subtract, I could add the 125x to both sides. So that way I'm working with positive numbers. So I get 125x is equal to 350. We divide by 125 on both sides. So with this, this is going to give us that x is equal to 2.8 hours, which is in fact less than the 3 hours. So the second flight would be the shorter time. For our last example, it tells us that f of x is equal to 250 minus 75x, and it represents the second flight. We already know that the first flight took 3 hours, so we're going to do the same thing, set this equal to 0. And then from here, I'm going to just move that 75 over by adding it to both sides. So I get 75x is equal to 250. And then I'm just going to divide each side by that 75. And I get 250 divided by 75 is 3.3 repeating. So which one takes the less time? The first flight.